Hello friends, this is Sujit Kamath once again. I am the Chief Data Scientist and co-founder of the AI Trainer.com. Today, let us discuss about how weights are adjusted in neural networks. In neural networks, weights will be adjusted automatically, but as a data scientist, it would be good to know how it is calculated, right? So let us talk with an example here. Um, Consider you have a house. You want to sell this house, and you know the age of the house. Sorry, second, give me a second. So you know the age of the house, for example. Okay, you have the distance from the city, how many bedrooms, age, distance, locality, and for say bedroom. So this what you have to sell this house. Okay, and you have the data set with many number of rows. So let us take only one row here. Okay? And this is what you have to compute the output, right? Is sigma m is equal to 1, y dash minus y square. So y is the actual price and y dash is the predicted price you are getting. So this is the normal way of computation, right? This is how machine learning and all works. It will take the features. Based on the features, it will calculate and it will tell which one is the best value. In neural network, here we are adding a layer of the neurons. So for example, now certain house you like people will be there to buy just considering the age and distance, right? You don't want to look other things, right? People will be interested just with the age and for say bedroom. So if age increases, your value of the house will reduce, right? Bedroom, like you might require 3 bedroom, 2 bedroom. So it depends. Based on that priority, they will not look into distance and locality. So they will go for this price, even though they will pay higher. Few other guys, they might look some other different parameters. Other guys will look all the parameters. Right? So here you are getting the different way of looking the same data, okay, and come out with the best price where you can sell. So this is the difference between your uh, um, machine learning and neural networks. Neural network will uh, go in deep and see what are the other ways to look into and come out with the probability. Clear? So now consider this is for one row, right? You have now n number of rows. So each row will be calculated in this fashion. Okay. Now you have, for a say y dash, you are getting value of 80, 88, and real value you are getting 90. So this difference, right? You have to try to minimize, and this is what neural network doing. So neural network, what it will do, it will, this difference is called the cost function, cost function or MSE, right? So MSE is equal to like half of sigma y dash minus y the whole square. Right? So you might have seen this equation many places. So this cost function or the this error rate, it will give it back. It will give it back, and it will try to adjust here. Okay, so if you have like a graph like this, for first row, this what you will get the predicted value, and this what you will get the real value. Sometimes you will get the real value this one, predicted value this one, real value. So y dash y, right? This is for each row. You can put it in a this fashion. Is it clear? Now let us start uh, with some computation. Just give me a second. Sorry guys, just give me a second. Okay. Now you have, for say, I'm giving you values, okay, like x1, x2, x3. x1 is equal to 1, x2 is equal to 0, and x3 is equal to minus 1. I want, also I am giving you the weights. So in our previous example, when you have the variables like this, and when you want to compute, you are multiplying with these weights, right? These weights are predefined initially, right? And then it will be adjusted. So all this will have this will have W2 weight, this will have W3. It's like that. So in this here, I wanted to ask you, right? I have the x1, x2, x3, x1, x2, x3 with some values, and I'm giving the weights also. W1 is equal to half, W2 is equal to 3 by 5, W3 is equal to 1. Okay, and also I am giving a threshold value is equal to 1, 0. So this is the determinant, right? So we need to see whether you are getting, like if you want to classify buy or sell or yes or no, you need to have match with some value. So this is what the threshold value. Now you need to predict y. What will be the value of y? Okay, so will it be more than 0 or less than 0? If it is more than 0, it is pass. If it is less than 0, it is fail. So here the equation will be W1 x1 plus W2 x2 and so on, right? So it will be half into x1 is equal to 1 plus 3 by 5 into 0 plus 1 into minus 1, that is minus 1. So this is half into 1, half plus 0 minus 1. This is minus half. So this is coming less than threshold value. That means it is fail. Got it? This is the simple equation. Now let us go to a little bit complex one. Okay, in this one, we have to define what will be the value of x and y, right? So I will be giving different examples. Sometimes you have to find it out, what is the weight, what or in other place what should be the value of x and y, right? So how it is getting adjusted based on, like, if we want to get some value and we are getting input parameters x1 x2 like this, then we have to adjust the weight. So all sorts of calculation you have to understand. Okay, so this is why we are playing with different types of techniques here. So in this one, I am giving you like weight is equal to W1, W1 is equal to half, W2 is equal to again half, and theta is equal to 3 by 4. So my handwriting is very bad. Forgive me. Let me try to draw once again. Uh, Let me try to draw. Looks very ugly. Okay. Weight 1 is equal to half, W2 is equal to again half, and W3 is equal to, sorry, I will strike it off. You will let us work it out with only two weights, and I will give you the threshold. Theta is equal to 3 by 4. You have to find it out, the x and y value. Okay, x and y. So the thing is, like, if it is more than 3/4, then it is pass or it is fail. Okay. So what should be the value of x and y? Let us try with different combination, right? X, y, 0, 0, 1, 0, 0, 1, 1, 1. So if you compute y, W1, X1, half of 0 plus half of 0, 0. In next case, half into 1 plus half into 0 is equal to again half. Yeah. Consider this example here. X1 is 1 and y is equal to 0. So if x1 is 1, half into 1, okay, half of x1 plus, let us consider y is equal to 0, is equal to 3 by 4. So what will be the value of x1? Is 3 by 2, right? So this way, if you compute, let us put it in some graph format, right? Give it here, x1, x2, x1, x2. Okay, and now you try to plot it. It is 3 by 2, 3 by 2. This is what we have got the intersection. So it will come like this, right? Now, in this case, you are getting only in the case of 1 and 1, right? Only in the case, like in the case of 1 by 1, you're getting half plus half, that is 1, which will, if you try to plot, it will come in this side, right? So if x1, if x2 is 0, x1 will be 3 by 2, right? And if x2 is x1 is 0, x2 again will become 3 by 2, right? So this some sort of graph you will be getting if you try to plot it. So guys, do you infer anything? What kind of graph it is? Is it kind like or and any sort of like that? Yeah. So this is kind of and, right? This and operator. Clear? This is simple computation we have done for the and. Now let us try to do for or. What you have to do for or? If you want to make this as or, okay, same example, like we will take a truth table. Let us draw x and y, 0 0, 1 0, 0 1, and 1 1. Okay. Now you have to define here what should be value of w2, w1, w2, and theta. In this example, you have to define this one. Please compute. Yeah. So w1 x1. Let us consider w1 w2 as 1, 1, and 1. Let us try to compute. So in this class, you have to try to compute with different values. It is a kind of a trial and error method, right? So you have to take your paper, pencil, and you have to draw. Okay. So W1, all three, W1, W2, theta 1. So here what you are getting is 1 into 0, 0, plus 0. Okay, it's equal to 0. 1, 0, 1, 0, 1, 1, 1, 1, 1. Right? Sorry. 1 plus 1, this you will get the 2. So only in this case, if you see, only both the values, if they are 0, it will come below the line, this line, right? Otherwise it will be passed. So when in the AND one we got something like this. In OR we will be getting like this. This is OR, right? 1 0 0 1, 0 0. Yeah. Now if you want to do with a uh, not operator, how you can do? Okay, in this not, let us make it simple. You have only one value, x1. Okay, so 0, this x1. Okay, here it is 1, here it is -1. So above 0 it is pass, it is yes or no. So what should be the weight here? This is for the not operator. So what is the truth value of not operator? Yeah. So only you are getting 1, 1 should be 0, right? So not operator you are getting, it should be reverse, right? Like if value is x is equal to -1, right? You have to get the value as 1. If it is 1, you have to get -1. So this is what you need to get. Okay, please compute what should be the value of W1 and theta. So here y is equal to W1, for example, let us take -1 and x is value as 1. Okay, so you will get -1, right? So this is reverse of x value. If it is 1, then you will for 0 this 0 only, right? So if it is -1, value is -1, then -1 into -1 is equal to +1. So in this example, like if we give W1 is equal to -1 and theta is equal to 0, this will reverse, right? All the values, like x value, if it is 1, you will get -1. If it is -1, you will get 1. This is how it is computed in a not representation. Okay, now let us talk about SOR, bit complex one. I want to give it to you. Okay, in this case, we have x1, we have x2. Okay, here we need to compute these boxes. Okay, this is and this should be the final output. Okay, great. So you have to find it out, these values in this, of course, right? You have to find theta, and this you have to fill all these boxes. So let me let us take the example, same example, right? X1, X2. I am giving you values like here X1, X2, 0, 0, 1, 0, 0, 1, 1, 1. And what should be the value of SOR? SOR value should be 0, 1, 1, and this should be 0. This is what we need to get it, right? Can you compute? Guys, I think I will give you some more clue here. Okay. Now, if you consider or, what should be your value here? And also and. So this will be 0, and again this will be 0. Here it will be 1, it will be 0, it will be 1, it will be 0, it will be 1, it will be 1, right? Now what can you infer from this? See, SOR and SOR and OR, they are matching all these three records, right? Only the problem is for this one. So that means it is actually, SOR is nothing but OR minus AND. Yeah, this is what, this is the clue I'm giving you, right? You have to compute, you have to put some values and see, you have to do all the ORs here, and you have to subtract with AND. That's it. Okay. So now let us take weight 1, weight W1 is equal to 1, W2 is equal to gain 1, and theta is equal to 1. So try to compute here, right? Here x1, here is 1, weight 1, x2 1. Okay, so in this case, x1 into 1 plus x2 into 1. So you will get all this. Yeah, you will get this 0, right? For the 0 0 you will get 0, no issue. In this case, so what will be the computation here? It will be w1 1 into 0, right? And w2 0 into 1 plus 0 into 1, and we will give, let us try to assign some value here. Okay, minus 1, this weight minus 1, minus 1, that means 0 minus 1 is equal to minus 1. Minus 1 is less than the threshold value, right? Threshold value is 1, that means it is 0. In this example, what will happen? 1 into 1 plus 0, 0 into 1 minus 1. So here we are getting 0. Is there any problem here? I made a mistake. You have to find it out. Yeah, for these two, you have to do it as homework, okay? Let us take this complex one. This will crib most. When you have 1 1, okay, that means it will be 2 minus 1, it will become minus 1, right? So this will not work. So you have to change here this to minus 2 here. Now see this. So 1 plus 1, 2, minus 2 is equal to 0. Got it? So this is how the computation works in neural networks. Weight adjustments. This will be really helpful if you know what is happening, right? How weights are getting adjusted. Suppose you guys are doing PhD and all, you have to understand this. Okay, guys, that's all I want to talk about today. Hope you got a fair idea of weight adjustment in neural networks. So in next class, we will talk about activation functions, and also we will see how this weights will be useful, and also we will talk about gradient, right? Stochastic gradient. Thank you very much for your time. Yeah, we'll meet soon. Thank you.